Welcome to BKW Physics. I'm Mr. McConley, and we've been working through some mechanics equations. We started with velocity, average is distance divided by time. We did acceleration is the change in velocity over time, which transformed into another equation. Well, it's the same equation, just rearranged. Vf equals Vi plus At. That's that equation rearranged. Most recently, yesterday, we did d equals Vit plus 1/2 At squared. We're going to add one more to that list today. So, backing up to actually what we were talking about yesterday, if I were to take Vf equals Vi plus At, and then that other equation that was based on the area, remember we had a graph, and last time graph was like this, and I said if you found the area underneath, it would give you 1/2 Vf plus Vi times T. And that's not on your reference table, but it serves a good purpose here because, once again, I'm going to take these two equations and I'm going to combine them to get a new equation. This time, though, I'm going to take this equation, solve it for T, and so in other words, take all this stuff here and plug it in there, which is different than what we did because when we produced the equation yesterday, we were actually producing an equation that didn't have any distance, it was distance equals, and then it had times. When we do it this way, we're actually, in essence, getting rid of the time, because there's a t in each one, and if we solve for the t and then plug it in here, now the t's gone. So we're going to produce an equation that doesn't have any time in it, which can be very useful because you don't always have the time when you're trying to solve a problem. So, to cut to the chase, you do some math, and you get Vf squared equals Vi squared plus 2At. Next one, on your physics reference table, which I'm still yet to give you. That's a Vf, velocity final squared, velocity initial squared, plus 2 acceleration times distance. So I guess the best way to check this equation out is to do an example. So I put an example up here out of a book, and let's see, I'll go ahead and highlight some stuff again. If I get the highlighting feature, we're going to do number 24 here. So we're looking at this problem right here. I think it was number 44 I tried here. Let me check that. Yeah, 24. Alright, so in 24 it says, a bullet leaves the muzzle of a rifle with a speed of 600. That is what? What did they give us? Leaves the gun. Initial.
What's the final?
No.
Maybe we got to read further.
It starts at 0, and then it's shot.
It's exiting. It's when it leaves the barrel, because it's the question is in lots of letters. That's fine.
So you've read ahead. I think when you read ahead, it becomes a little clearer, because blah blah blah. What's the acceleration of the bullet while in the barrel?
All right.
So if you're talking about the acceleration in the barrel of the gun, that's the long part that the projectile is going to shoot out of. Then that 600 is the final speed because it started way back here at a speed of what? Okay. So what you know is that, that doesn't work too well in that color. Let's try this color. You know that the initial velocity, this is sloppy, is 0. And it just went off the edge. Oh well. So, you know that the initial velocity is 0, you know the final velocity is 600, and the barrel of the rifle is, what they give us there, 0.9 meters. That's a distance. And they want to know, question mark, what is acceleration? Alright, so let's move over here and see if we can apply this. What am I trying to solve for? Acceleration. I think what I should do first is rearrange the equation because that's how I taught you to solve these problems. Let's go ahead and do it. I got to get to that. So I'm going to get rid of the VI by subtracting it to the other side. So we got VF squared minus VI squared equals 2AD. Remember, I'm trying to find the A. So to get the A by itself, I'll divide both sides by 2D. So what I'm left with is that A equals a VF squared minus a VI squared over a 2D. Good.
We have correctly rearranged.
Now let's plug in our numbers. Final speed. 600. Do we need the units on it? Of course. Meters per second, and we square that. That's going to give us a pretty big number. 600 squared is a hefty number. Initial velocity, though, is not going to give us much of a hefty number at all, because initial velocity is 0. So I can put a 0 in, but I don't even really have to write the term, to be honest with you. Since it's a 0, it's gone anyway. But I'll put it in just for completeness sake. And then 2 times the length of the barrel, which is, everyone? 0.9. Anyhow, someone's on their calculator probably. Get the answer yet? Get the answer over there? Yeah. Yeah, I got that too. Okay? So the acceleration is 200,000 meters per second squared. Notice I've shown the correct answer with the correct units. It's pretty high acceleration, but this is a rifle. And you would expect pretty high accelerations in a rifle. Because it's got to get up to a really fast speed before it leaves the end of the gun. After it leaves the end of this gun, can it speed up anymore? Why not? Why can't it?
Yeah, because it loses all of its technically.
Okay, so under conditions like no wind, nothing crazy going on here, will it speed up anymore? Yeah, that could make it speed up, right? So if the wind were just blowing the right way, whatever, it could actually go a little bit faster as soon as it left the gun. But in most situations for high school physics, we say as soon as it leaves the gun, there's nothing pushing it anymore. There's no more, it's not going to speed up anymore, it'll only start slowing down from that point. Okay? Shot it off the cliff. I'm going to come back to that on another lesson for today, physics.